All right, let's take a look at momentum. That's the next topic here, and it's very interesting. Momentum is defined as a quantity. It's the product of the mass and velocity of an object. So here's an equation you can add to your season 6 equation sheet. And you think about like this guy biking down a hill, right? As he bikes down a hill, right, gravity will pull him in an increasing speed. And so in our own lexicon, right, in English, there's sayings such as, we could say his velocity is increasing, but we could also say that his momentum is increasing, right? Because as he goes down the hill and his speed increases, this component, the V component of the momentum, gets bigger. Momentum, the symbol here is a P, and then it's the mass times the velocity. So the units of momentum are kilograms times meters over second. Okay, and this unit does not have a name. I will sometimes call them moms, but they really don't have a name. So it's kilograms meter per second is the unit of momentum. And we see as he goes down the hill, his momentum increases. So if you think about a situation where we had a really small object, say we had a hailstone, right? Very tiny. If I just threw a hailstone at you, it wouldn't hurt. You wouldn't be afraid because the hailstone has a very small mass, right? And so we know it's not going to have a lot of momentum. But if that same hailstone were to fall from high in the sky and fall down, now its velocity would be big. And even though it has a small mass, it would have a much greater momentum and could do much more damage and even end up hurting you or denting your car or breaking a window, something like that. So here's a real life example of how momentum is a product of mass and velocity. And so if you have a really big velocity, you can still have a small mass and have a big momentum. So we can see in this case, even though these are tiny hail pellets that are falling, they're doing damage to the car, to the hood. This is a serious weather situation. So, and it's all because the momentum is so great. But you can imagine if we had a huge boulder at the top of a mountain, right? If I had a huge boulder at the top of a mountain, that boulder would have, and if it wasn't moving, even though it had a huge mass, it would have no velocity and therefore no momentum. It would have no ability to apply a force, right? Okay, so I'll stop this video. I don't know what he's saying, but it's probably something about hail. We'll watch one more video of a really small object that, when it's used, has very great momentum, and that is a bullet, right? So a bullet has a very small mass. So you're like, well, how can a bullet do so much damage? It's because bullets are fired with such great velocity that they have a great momentum. In other words, they have a great ability to apply a force going through objects. So this is slow motion of bullets going through some different objects. It's pretty interesting, so enjoy. All right, so let's try this on for size. Let's do a practice problem here with momentum and see if we can apply it mathematically now that we understand the concept of what momentum is. Okay, so here's a problem, and this is from your book. If you want to use your book, this is page 199 in the textbook. So it tells us that we have a 2,225 kilogram pickup truck, has a velocity of 25 meters per second to the east. What is the momentum of the truck? Well, if I have this truck and it's moving this way, we'll say that's the east direction, right? Its velocity is 25 meters per second. The first thing I can see is that direction matters for momentum. All right, so it's important here in this example, and that's why we're doing this example. Momentum is a vector quantity. And you might ask, well, why is it a vector quantity? Well, it's because if momentum is mass times velocity, right? It's the product of mass times velocity. In physics, any derived quantity, a derived quantity is something that you use fundamental constants, so in this case mass and velocity, that are either multiplied, divided, added, or subtracted to get a new quantity. That's the derived quantity. If the derived quantity has a vector as one of its main units, then the derived quantity is also a vector. So these are both vectors. Momentum is a vector, and so is velocity, remembering our vector notation from season 1. Okay, so momentum is a vector. So then in this problem, what are the things that I know? Well, I know the mass of the truck. I know the mass is 2,250 kilograms. I also know the velocity is 25 meters per second. And then I'm just going to put east in parentheses. So we're trying to find the momentum. Right, so I'm trying to find momentum. So very straightforward here. This equation, we're going to just apply. We're going to use the equation, our only equation that we know for momentum, and that is momentum is mass times velocity. And of course, we're going to multiply. This is very easy for you. 2,250 kg times 25 meters per second, and we get a final answer of momentum is equal to 5.6 times 10 to the 4th kilogram meter per second, and that's to the east. All right, so that's a very straightforward momentum problem. And I hope that was momentum was fun.